Well, hello, welcome back to the second part of the 1.1 notes. We're going to take a look at our units of measurement in this video. So back to our notes here. And now we're moving into the second part, as I said, of today's notes, which is units of measurement. How will we be measuring things in this class? So we're going to use what we call the SI, which actually stands for the System International. It's French. We'd probably call it the International System, but the French do things a bit different. And we're going to be using SI units of measurement. So how they work, they're much better than our American system, to be honest. We're just a lot more familiar with our American system, but ultimately it's going to be a lot easier once you get the hang of it. You don't have to remember how many inches are in a feet or in a foot. You don't have to remember how many feet are in a mile. You don't have to remember how many cups are in a quart and how many quarts are in a gallon. It's a lot easier when you learn the base system of the metric system. So it starts off with base units. And it's just, very similar to ours. So again, our base units are the feet. Base units are the pound, the gallon. They have the same exact idea in the SI system. For length, instead of using feet, we're going to use the meter. Which we symbolize with just a lowercase m, like that right there. For mass, we use, again, in America, we'd use the pounds. They use the kilogram, which I've always thought kind of weird. The base is kind of the gram, and kilo just means 1,000 of them, yet we're using a prefix with a base for the base, but anyway, the reason for that is a gram is a very small unit of measurement, and a kilogram is a much larger unit of measurement, a lot closer to the mass of a pound. So it works a lot better. So for that reason, the kilogram is actually the base for mass. Time, they use the second. Hey, finally something we agree on. And finally, for temperature, you might be thinking it's degrees Kelvin, and I'm sorry, degrees Celsius, and it's not. For the SI system, we actually use the Kelvin for our temperature, which is symbolized with a large K. Not to worry about it. We actually won't be dealing with too much temperature until much later in the year, but there it is for when we get to it. All right, so how the SI system works is we have these base units, and we add prefixes to them, and the prefixes mean different things. And the way that you use the prefix tells you how big or small or how far from the base you are. Again, it's kind of like saying, well, if I have 5,280 feet, I have 1 mile, except that's a difficult number to work with, 5,280. Instead, with these prefixes, we can always just say, centimeter. And that centi means the same thing. It can say a centimeter, I can say a centigram, I can say a centisecond, and it always means the same thing. It always means 1/100. There are a lot of prefixes. In fact, I'd probably think every single value has some kind of prefix. But for this class, these are the ones you need to know. Kilo, which we represent with K. In fact, we already saw it up here for kilogram. That means 1,000 times the base. So again, whatever your base is, 1,000 times the base is a kilo. That's what the kilo tells us. So 1 kilometer, kilometer, 1 km is equal to 10 to the third, that's 1,000 meters. I'll go ahead and change that to 1 times 10 to the third, so I have a better scientific notation there. So 1 kilometer is 1,000 meters. Again, that's kind of what that K tells us. 1,000 of whatever follows. There is a number that is bigger than kilo. We just won't work with it much. There are numbers smaller than kilo, like hecto is 100, and deca is 10. But we're not going to work with them very often. The next big one to know is deci, which is a lowercase d, and that represents 1/10 of the base. And again, so anytime you see that prefix d in front of one of these units, that means you have 1/10 of the base. So 1 decigram. So we have the 1 there. Sorry about that. 1 decigram is equal to 1 times 10 to the -1 grams. 1/10 of a gram. You can think again, you can think about that 1/10. The 10th column is that first decimal behind the first column behind the decimal. So there's our 1 bump over. The next one is probably familiar to you, at least a little bit, and that is centi. Centi, 1/100th of the base. We actually kind of use this one in our money system. 1 penny, 1 cent is 1/100th of a dollar. So 1 centimeter is 1/100th of a meter. Again, bumping that decimal to the right. Next up, and again, you may have heard of this one, milli. So 1 milli is 1/1000th of the base. So if you have a milligram, you have 1/1000th, moving that decimal point 3 times, 1/1000th of a gram, so a much smaller number. This next one is probably new. I'm guessing you've heard of some of these, but this next one maybe you haven't heard of. Our next smallest one is micro. And the symbol for micro kind of looks like a U with 2 tails, lowercase u with a tail in front and a tail behind. It's actually technically the Greek letter mu. We've already used our lowercase m's. We've got our milli here, we've got our meter there. So we needed another M for micro. So we went to the Greek alphabet and got their Greek letter M, which is Greek letter mu. And micro is 1/1,000,000th of the base. So microgram is 1/1,000,000th of a gram. Very small amount. And then finally, again, they go smaller. There are a lot more prefixes, but the next one we're going to work with, the last one we'll work with is nano. Nano, very small amount here. This is 1/100000th of a gram. Excuse me, 1/100000th of a base. Could be a gram. If we had a nanogram, it'd be 1/100000th of a gram, or we could have a nanosecond, 1/100000th of a second. That'd be a very quick amount of time. And these are the prefixes we're going to use most common for this class. So make sure you guys commit these to memory. These are prefixes. And again, how we use them is we just put that prefix in front of one of the base, and K means 1,000. Doesn't matter what base you're using. K means 1,000. If I could be talking about dollars, I'd love to have a kilo dollar, $1,000. Whatever the base is, kilo in front means it's 1,000 times that. Deci 1/10th, centi 1/100th, milli 1/1000th, micro 1/1,000,000th, and nano 1/1,000,000,000th. So those are the units we'll be using in this class. Next up, though, we have what we call derived units. So the base units we gave you are, you can measure length, you can measure mass, you can measure time. Derived units means that they're calculated. A big unit that you just saw we didn't use, you're probably familiar with it. I know in the English system you are. Volume. Volume is a derived unit. You guys hopefully remember the formula, not that it's Not that it's terribly important for this class, but length times height times width. Those are three length measurements, L times H times width. So our units for this derived unit are centimeters times centimeters times centimeters. We'd measure the length in centimeters. We'd measure the height in centimeters. We'd measure the width in centimeters. So our volume, our unit for volume is centimeters times centimeters times centimeters, or centimeters cubed. Anything times itself 3 times is going to be cubed. 5 times 5 times 5 is 5 cubed. 2 times 2 times 2 is 2 cubed. So the same thing goes for centimeters. When you have centimeters times centimeters times centimeters, centimeters cubed. So that's volume. Technically, the SI unit for volume is cubic centimeters. A lot of times hear it called CC. Like if you watch medical dramas, like a doctor oftentimes shouts at 850 cc stat. Well, CC is cubic centimeter. But there is another common unit that we'll use a lot. It's not technically the SI unit, but we do use it a lot. And that is the liter. Even here in America, we do use this one. You oftentimes go to the store and buy a 2 liter of soda. So that's 2 liters of soda. So this is a common one. Again, I know over in Europe, they use this one a lot. Technically, cubic centimeters is the SI unit, but we'll use this one a lot as well. Some very, very helpful calculations, conversions. 1 liter is 1 cubic decimeter. Now, we don't use decimeters too often, so this one would be good to know, but not something you absolutely have to. This next one, though, oh, you use this a lot in this class. 1 milliliter is the exact same as 1 cubic centimeter. So these two, this one here, circle it, put a star next to it, whatever you want to do. This is a big conversion. You're going to use this one a lot. So make sure you guys are familiar with 1 milliliter as 1 cubic centimeter. All right, so that's volume. We have one more derived unit to talk about, and that is density. There are a lot of derived units, but these are the big ones we'll be working with, volume and density. And density is mass of an object divided by the volume of the object. Mass over volume. The units, well, we measure mass in grams, and we measure volume in milliliters. Or, again, we just talked about this, 1 milliliter is 1 cubic centimeter. So it could be grams per milliliter, or it could be grams per cubic centimeter. So there's our two potential density volume or density units there. All right, let's take a quick look at how this works, setting up some example problems here. So a piece of platinum metal, it has a mass of 96.4 grams and a volume of 4.49 cubic centimeters. What is the density of this metal? Okay, well, the best way to do this type of problem, and we'll go over this throughout the year, so might as well build these habits now, is say, okay, what are we looking for? Question mark, what are we looking for? We're looking for density. Our units for density are grams over milliliters or grams over cubic centimeters. I'm going to look back into the question. I'm going to see, hey, that's cubic centimeters. So let's do ourselves a favor right from the beginning. Not that it's a difficult conversion to make, but might as well start by using that one. So we're looking for grams over cubic centimeters, mass over volume. Well, let's take a look here. We have 96.4 grams. And we have 4.49 cubic centimeters. There we go. Our units are set up exactly how I want them, grams over cubic centimeters. So take out my calculator, 96.4 divided by 4.49. And there's our answer, 21.5 grams per cubic centimeter. We'll discuss where and how to round next week. So for right now, we'll just say 21.5. Make sure you've got a unit on there. Units are everything in this class. So 21.5 grams per cubic centimeter. Got one more example for you. All right, so the density of ethanol is 0.798 grams per milliliter. Calculate the volume in milliliters of 17.4 grams of the liquid. So same type of problem, but this time they're giving us the density and asking for us to solve for either the mass or the volume. Let's see here. Calculate the volume, and they tell us specifically in milliliters. So again, I'm going to start this off. What am I looking for? Question mark. Milliliters is equal to. Now I look back at my question here. Big helpful guide. Whenever possible, choose. So I've got two values here. Choose the value that only has one unit. You see how this one only has one unit, it's just the grams, whereas this one has 2 units, grams per milliliter. If ever you can help it, stay away from the double unit. We'll go with 17.4, just plain old grams. So just our single unit. Okay, well, grams are not milliliters, which means we need to make a conversion. This is where our grams per milliliter is going to come into play. And again, notice I don't want milliliters in my final answer. Don't want that. Excuse me. I do want milliliters in my final answer. I'm sorry about that. I don't want grams. So we need to cancel the grams out of this equation. We do that by dividing by grams. 5 divided by 5 is 1. 2 divided by 2 is 1. Grams divided by grams is 1. They cancel out. They'll no longer be there. We need to get those grams out of there. So grams there, I can put milliliters on top because that's what this conversion right here is. Now we do have to watch out though, that 0.798 goes with the grams. So that needs to go on the bottom. 0.798 grams per 1 milliliter. And that's kind of what that's what that density tells us, 0.798 grams per 1 milliliter. So there we go. Grams is canceled out. We're left with the unit milliliters, which is exactly what we were looking for. This is great. We're in great shape. When we've got our problem set up like this, we'll just multiply across the top, divide out the bottom. You don't necessarily have to do the multiplication on the top, though. When there's a 1, we know our identity property from math. That 1 won't do anything. So 17.4 and divided by numbers on the bottom. So divided by 0.78798. Enter. There we go. Ethanol has a density of 0.798 grams per milliliter, and we have 17.4 grams. That means our volume, 21.8 milliliters. There we go. So that's how we solve a problem like that. Again, big things. Make sure you watch out. Get your the number with the proper unit. And make sure whenever possible, start with the value that only has one unit. It's possible to do if you started with this value, but it's going to be a heck of a lot harder. So choose the one that has just a single unit there. All right, well, that wraps up today's notes, 1.1. So join us again next time when we get to 1.2. I'll see you guys later.